I'm excited to give you guys an update with the LS430. This car has just been sitting, doing absolutely nothing. It's just been parked. And I haven't driven it. I haven't done anything because it needs new tires. These tires shake and yeah, they're just Vogue tires. They're not good. But more importantly, there's a problem I cannot fix with this car. Let me show you. Because, oops, I don't have to start it. But look at this. Well, maybe we do have to start it. So, the AFS off light. I can't fix this problem. Keep watching and maybe you can help me figure this out because I am stumped. But before we talk about that, let me show you what I did in the meantime. So we've got brand new OEM wipers, and this is a very little known fact, but you can buy the factory metal wiper housings, and then the blades, the rubber blades, are replaceable. So when these wear out, you can just pull them out and put new ones in. But the factory blades, the metal blades, very important because those, you can't get that quality in aftermarket wiper blades. Now, what else did I do to the LS430 in the meantime? We talked a little bit about some of the stuff I was going to do. This cover is on, so unfortunately we can't see anything. But actually we can see the belt because it happened to stop right on the brand. So I got rid of the Daco belt, and hopefully you can see in that little gap. Maybe not. I can see it, so hopefully you can see it. But I got a MitsuBOSHI belt. So there's two different serpentine belts you can get for this car. The first one is the MitsuBOSHI 6PK2240. That one's made in Japan, and there's another belt by another manufacturer. I forget the name, but it's not made in Japan. So there's two different serpentine belts, two different part numbers for the LS430. I got the Boshi because, you know, that's just me. The other thing, what else did we do here? Oh, so there was a PCV hose that likes to turn just absolutely rock solid. I replaced that. I replaced the PCV itself. And what else? There's not too much else because everything is just perfect on this car. We did, I didn't film it, but we replaced the seat blower. So there's a blower under here that circulates either the ambient air as like AC or cooled air, and then I think the seat heaters themselves are just pads. They're not actually the heated air that comes out like the 460s. I could be wrong, but I'm pretty sure. So we replaced that because I was making a bunch of racket. What else? That's about it. So this AFS issue, we'll kind of get into that. But I'm at a loss. I'm stumped. I've been stumped for a few weeks just trying to wrap my head around this problem, and I can't figure it out because it just doesn't make sense. So let me show you how to test the rear AFS sensor, because that is the most common reason for the AFS code. And then once I show you that, it'll give you a better understanding of my dilemma and my problem that I can't figure out. So let's get into that. So here's an overview of the issue. So this is the driver's rear AFS sensor. So what this does, it detects the height of the control arm essentially. So there's a maximum and then a minimum. Now typically these, if we open this up, if you live in a rust belt area, or there's snow, there's salt, there's nasty stuff, what you're going to find is you're going to have a blinking AFS light, and you're going to take this sensor apart, and it's going to be all corroded inside. Be careful, there's springs. So you see there's 3 springs here. These would be all corroded, rusted. There'd be corrosion all over here. But essentially, this pad, these traces, the springs line up with the circles, and then as this moves, it changes the value or the resistance or the voltage coming in, and alters it going back to the ECU. So this is fine. There's nothing wrong with this one, and then we'll actually test it in a second here. So here's an overview of the circuitry, schematics, whatever you want to call it. There is a height control sensor in the front, so the front driver's control arm has one. This one rarely goes bad, if ever, but this is the one we're looking at here. And if you have air suspension, that also ties into the AFS ECU. And if you don't have air suspension, it just kind of like deletes itself from the schematic. So here's the AFS ECU. This is behind the glove box. And what this does, it controls all aspects of the AFS system. So if we go here, this is kind of your flow chart. So trouble area, headlamp leveling motor, swivel actuator, and AFS off indicator light. So it's going to tell you exactly, like, if this happened, then this happens. So if you notice, when your headlights are on, you turn the ignition on to on and not start the car. You can start the car too, but you'll notice your front headlights kind of go left, right, up and down possibly. That's just the motors testing in the headlights. So there's little motors inside the headlights that turn the headlights when you turn. So it says right here, like, for example, vehicle speed sensor signal malfunction, one side. So it says the control continues, however, the swivel actuator stops operation after returning to initial position. So you might see it, the actuator, and then it'll just stop in the initial position. And then AFS indicator, it blinks for all these situations. So it could be more than just the sensor, but typically it's the sensor. So leveling, steering sensor, if there's a problem with your steering sensor, then here is what the headlights will do. It'll stop at the current position, and then it'll return to the initial position after 10 seconds. You can figure this all out by just hooking up TechStream and pulling the codes, but we'll just jump right to our problem, which we believe was the rear sensor. So, vehicle height signal malfunction. That is our problem. I don't remember the code offhand, but there is a code. So, stops operation after returning to initial position. Fail occurs at higher than initial position. If the fail occurs lower than initial position, then it'll stop at the current position. So the problem we're having is we'll get the headlight adjustment on power on, and it'll just stop after coming back to center or forward. It'll just stop and it won't move anymore. So that's the problem we're having, height signal malfunction, and there's a whole slew of steps to test the flow chart, like what do you do first, what do you do second. So just to give you an idea, the AFS ECU here, it will output a 5-volt signal through these 3 connectors, well, the ECU connector, 2 additional connectors into the height control sensor. So pin 1 here is 5 volts in. Now this is important because this is going to relate to our problem that I can't figure out. Then there's a ground, obviously, and then depending upon the position of the arm, up or down more, it's going to output anywhere between 0 and 4.5 volts back to the ECU. And that is going to tell the ECU, hey, the control arm is in this position or this or that, and adjust the headlights accordingly. So the problem I'm having is With the sensor unplugged, obviously it gets 0 volts. With the sensor plugged in, I'm getting almost 5 volts. So I'm basically getting the 5 volt return no matter what position the arm is in. Which doesn't make sense to me because we tested this and we know this is working. So how could it get 5 volts in through the sensor and still return the same 5 volts back to the ECU? And I did try a new ECU and we're having the same problem, so that's entirely ruled out. So now at this point I'm wondering if it's a problem in one of these connectors or wiring. I'm stuck. I don't know. So with that said, we're going to go ahead and test the sensor. So you need a voltmeter. I have a power supply, but you can use a few batteries in line like this. You just don't want to exceed 5 volts to the sensor. And then here it tells you at which degree position is your voltage. So 1/2 volt, 2.5, and then 4.5. So we'll hook up all the wires and we'll do some testing here with the multimeter and see what the sensor gives us. Alright, so here we have our 5 volt input. You can see that right there. And the rightmost terminal is 5 volts in, the left is ground, and the center is our essentially our output. Alright, so now we have, let's go to the extreme here, and you see we have 0.5 volts. So that's correct. And then as we articulate this arm, you can see the voltage increasing all the way to 4.57. So why, if I'm replicating this on the bench, why is my output almost 5 volts regardless of where this arm is? That's what's not making sense to me. So we're going to go inspect that on the car and see if we get the same results with the sensor, and hopefully we can find some kind of answer. If not, you guys are going to have to help me out because I'm kind of at a loss here. So let's move on out there to the car. So here you see our AFS light is blinking. Here's our code, B2416, height control sensor. It would be nice if they differentiated between front and rear, but that's not a problem because you can just see it here in the data list. So click that, and then you can see right here, so front height sensor, signal value 2.25, so that's normal, kind of right in the middle. And then we look at our rear, and we're almost at 5 volts. So that's the problem. How are we getting 5 volts even though we have a good sensor installed? Huh. That is strange. This is strange too. The steering sensor center position, 3072 degrees. Interesting. So right here you can see the sensor. This is the driver's rear control arm. Here's where the arm bolts to the bracket. Now you can see this can be adjusted in various positions. I don't know what the procedure is, or where it should be, or if the voltage should be the same as the front. But typically, obviously, if you manipulate this, your headlights are gonna not be correct. It's gonna either be too high, too low, whatever. So follow whatever the procedure is on where this has to go. But here is the sensor we're dealing with, and it's at 5 volts right now, as you see, but it's in the middle. So that is the confusing part. Now we can take off the plug here and measure voltages, but we're going to get probably the same thing. The plug itself, the pins are fine, there's no corrosion, they're nice and gold colored. So I think really the next step is to kind of find out where this goes, and it looks like it goes into the trunk, kind of in the spare tire well. It goes up, and then you can see it loop around right here, and then it goes into the trunk area, spare tire well. So we'll have to go in here and maybe pull the next connector, do some measurements in there, and see what's going on. But let's, just for the record, we'll do some measurements at this connector and then see what it's giving us. Alright, so here you can see the rear sensor is now at 0 because it's not plugged in. So that's fine. So let's do some measurements at the connector. So here's that connector in the trunk. This is just where the first junction is. So as you can see, it's our three terminal thing again. And let's just see if we can get a reading here. We're gonna have 5 volts because that's what's measuring at the sensor. So there you go. So 5 volts is coming from the ECU to this connector. Now the center pin, that's what's feeding back to the ECU. So actually I have an idea. What if we manually feed 2.5 volts back to the ECU? Will that clear the code? I'm kind of interested in that. Before we, I've already tested the sensor and that's not giving me the answers I'm looking for. So let me try that. We're gonna bring our power supply out here, and we're simply gonna feed 2.5 volts back to the center pin and see what happens. See if that clears our code. Alright, so we're putting 2.36 volts back into the ECU. We're just feeding it directly into here. So let's go see what that did to our codes. Alright, look at this. Rear sensor, 2.35 volts. And we have no AFS light on. So isn't that interesting? Go to trouble codes here. Nothing. So we know for a fact that the whole system works fine, and this should tell us that absolutely 100% the sensor's bad, right? You'd think. Yeah, I don't know. I'm kind of at a loss as well. So we're basically fooling the system, I guess. I don't know. This doesn't make sense to me. Let's try something else here. I actually want to see if we can manipulate the voltage to raise and lower the headlights. So let's see what happens with that, just to see. Okay, you'll see now this is with the voltage at 0. You'll see kind of where the line is way down here. That's basically making it seem like the car is lowered, compressed. So obviously if you lower the back of the car, the front of the car is going to raise up, and it's going to say, hold on, we need to aim this further down, otherwise it's going to be way up here. So 0 volts, we're right here. Keep that in mind, just kind of under this pipe, and then just about right at the hood area. And it seems like you can it'll only make changes when you start the car. You can't like do it on the fly. So let's hook up the camera here, and then we're going to keep an eye on that line, and I'll show you what I mean. We can even do it just so I can show you. So here's kind of when you turn the car on, and of course it's not working. And now it's not, oh there. So see, it goes up and then down again. That's kind of the initial test. So now we're going to crank up the voltage and see where that line ends up. So we'll shut this off. We're up our voltage to 5 or 4, because it gets mad at 5. So this is 4.5. This is going to be fully extended as if the back end is raised up. The front end's going to be pointing towards the ground. So look at that. Look how high that is now to compensate for it. It thinks the rear end is pointing kind of straight up in the air. So that's how the AFS system works. It just adjusts the height of the beam essentially with the weight of the car, what's in the back, what's in the front. Not so much the front, but definitely the back. If you have stuff in the trunk or passengers in the back, it's going to adjust that beam to compensate. So let's go back under the car, check the sensor, maybe put another sensor in and see if we can get some kind of correct values with a replacement sensor. Okay, here's our sensor detached. Now we've got full range of motion, so this is fully extended. So if you remember, this should be almost 5 volts or 4.5 volts, and we're at 4.98. So 4.98 volts, and here I'm moving the arm right now all the way back, so that should be almost 0, and it's not moving at all. It's just 4.96. So help me understand this. Like, what? I don't understand. The sensor's good, but it's just sending back 5 volts. Let me try another sensor, the one we just tested on the bench, because if that does it, you know, I'm at a loss. Let me swap this out. Okay, got this one out. Now our voltage is 0, obviously, because there's nothing. Now here's the new sensor that we just tested. Plug her in. 4.98 volts. Same exact problem. This makes no sense. There's absolutely no change. It's just like the voltage is essentially passing directly through the sensor and just going right back to the ECU. But if the sensor is good, how is that even possible? That doesn't make sense. I must just be missing something stupid. I don't know. I have 2 more sensors we can try. But again, you know, I don't know. Let me see if we can figure it out. Okay, if you remember from earlier, we should be getting the 5 volt reference from the pin on the right. So when the sensor's plugged in, remember on the bench it was like this, and then we fed 5 volts on the right, ground on the left, and then our return was the center. So this sensor changed the output of that center pin. So what we can do is, let me just make sure, yeah, so the right pin here, that should be our 12 volts, or 5 volts, sorry. So let's see what we got, and then this left pin then should be our ground. So let's get that in there, and we have 0. So that's odd. Look at this. We've got, I need a better connector for this. We've got 0 volts where we should have 5. Okay, that's weird. We just checked it though in the trunk, and we were getting good voltage. So could this harness be bad? Could this plug be messed up somehow? I don't know. Let's do the middle. Middle to ground. Come on, what is going on? Middle to ground. Okay, that's still 0. Well, where's our 5 volts? Let's do what's supposed to be the 5 volt positive to the center. We've got negative 4 volts. So how is that a thing here? Okay, center to our source. So we have 5 volts. Why are we shouldn't be grounding that center wire though. That's the thing. That center should be our return. So now I'm getting 0.28 volts on the the ECU. Yeah, this is odd, because we definitely checked it in the trunk and 4.69, and we're grounding the return. Interesting. Very interesting. Well, well, well. Look what I found. A broken wire. Oh, this is satisfying. So for some reason the wire was just broke. I don't know. What I should do is get a whole new harness, because this is questionable. But that looks like our problem. I was able to, there's a clip on top of the subframe that holds this, and then I pulled it down to get some more access. But assuming I didn't do this when I just pulled it apart, that's our problem. So let me fix this. We'll do solder, and then some heat shrink, and then electrical tape, and test the tape, and then we'll check our values again, because that should give us what we need. Alright, let's do this repair together. So first thing you probably want to do is get your heat shrink tubing on the wire so you don't forget. So we're just going to slide that on over. I'm not going to use a crimp connector here because the wire is so thin. It's just best going to be soldered, and then yeah. So let's strip this a little bit. I don't even know. Yeah, it worked. Yeah, the wire looks okay. It's not like green or anything. So that's good. And let's check this one. I don't know if this just got brittle or like what happened, but there's a little, so you can see a little green. I don't know if you can or not, but right at the break there's some green tint on that wire. So that, I don't know, for whatever reason, maybe the cable is just bent that way, and just the wear and stress on it. I don't know. I'm assuming this is the problem. I mean, I guess we'll find out. Alright, so the heat shrink is big enough that we don't have to worry about bending it over or fitting. However, I'm just going to butt them together, essentially. So, yeah, and this wire is a little... We're going to have to sand this wire because it's not soldering well. So I'm going to get some sandpaper. We'll sand this nice and gold, both sides, and then continue on. Well, here's the sandpaper. This is what I call like a temporary permanent fix, because I mean, honestly, you'll probably never have problems with this again, but I do want to get a good harness from somewhere that was not in the corrosion zone, and just replace it at some point, but this will do for now. So what we're just cleaning up the strands on this wire so solder will essentially stick to it, and we get it nice and gold. This is a common issue too on like trailer wiring. That stuff that corrodes so badly and just rots. Alright, I think that's good enough. Let's do this side. I don't know if there's any kind of spray that would do this too, but essentially you can use your fingernail too, even that sometimes works, but for our purposes we'll do the sandpaper. Alright, so now car's off. Obviously there's no power going through any of these wires. Okay, now we're getting some good adhesion. Not the best, but we're getting something. Oops. I don't know if we can add some flux to this and see if that helps. Let me go grab some flux and see if that helps our problems here. So this is the CW8400. It's the lead-free flux dispensing pen, and this just promotes you know, the bonding process essentially. So put some of that on both ends. They do make like a paste flux that you can put on too, but we'll see what this helps us in any way, shape, or form. Alright, if you're wondering why I'm using a giant desoldering gun, it's just easier to grab and pull out in the garage than to move the whole soldering station. So you can see how much better that solder basically sticks to that wire, if you want to call it that, or melts into it. So that's good. Let's do this lower side here. If the wires are really bad, I mean, your only hope is probably like a crimp connector, because solder is just never going to work on something that's super corroded or green. It'll just never work. Let's try to hold everything with two hands. Some heat in there. Yeah, this side's not the greatest, but it'll work for our purposes. I mean, honestly, we could just tape the wires together too, because it is a temporary fix, but I don't roll that way. So now what we need to do is basically just butt these together so the heat shrink will slide right on over them. If we twisted them together and then soldered it, it wouldn't work in our favor, because it would be too fat. Okay, that looks good to me. Let me move that out of the way. A little messy, but it'll work, and it's holding. So let's slide the heat shrink over there. And of course, all I have is a map torch. I don't have a proper thing, so I'll just have to be careful here. Okay, that also looks good to me. And we've got all three of our wires connected again. Now what I like to do is Scotch Super 33 Plus. This is the best electrical tape you can get. I used to be an electrician, and I used to use this when it was like 10 degrees outside, and it worked fine. It was sticky still. It taped everything I needed to tape ever. And you know, I think it's $4 or $5 a roll, but you're never gonna go back to any other kind of tape once you try this stuff. So this is good for any kind of wiring. This is not good for engine bay wiring or anything that gets super hot, because this will get sticky and it'll just kind of disintegrate. I'm just kind of showing you different tapes here essentially, but you know, you can use this. It's not necessary because it's just not. We've already done heat shrink on it. Now the harness, I will show you what the other version of the tape is for harnesses. I'm going to sneak this back in here. And this is difficult if you don't have good dexterity in your fingers. And it also helps your fingers maintain that dexterity. This just clips together with a little clip there. There's some more random tape that's coming out of here. Let's get rid of that. Alright, now we've got the Tessa tape. This tape is like a fabric tape, and this is what you want to use for engine bay looms, anything that gets hot. It would work great for here, just to hold this harness together. It is tough to rip. You need some kind of a knife or cutters to cut it. That's the only thing that sucks. But essentially you would use this stuff. That looks terrible, but whatever. Again, it's just temporary. You would use this stuff every 6 inches or 12 inches just to hold the harness together, so you don't have these gaps, basically, just like that. You could go over this, but that's not how the factory did it. For our purposes, you know, that's good. So let's plug this back in, and hopefully that fixes the problem. We'll get some readings and check it out. So here's our connector. Our right plug is 5 volts, should be feeding from the ECU, and we will touch that to our repaired ground, and look at that, 5.04 volts. The center, so if we do ground left, can't really see the plug, sorry about that. Left pin over here to the center, that's our return back to home, and we're getting 0, so that's correct. So let's install, well, we don't even have to install, we can just plug it in. So let's plug in a sensor right here. Alright, so we got our sensor plugged in, and if you remember from earlier, this should be about 4.5 volts, so fully extended, somewhere in there. And if we look here, I will highlight this for you, but we are at 4.51 volts, so that is exactly where we want to be. Now let me move the sensor back up. Remember, there's a delay with this cable. 3.3, we're getting the correct values on the voltage. 1.88. Oh, look at that. It's fixed, guys. We did it. Yay! Alright, that's it. Time to go home. So the last part of this essentially is I'm going to set the nut in the arm in here so that it basically matches the front voltage. So I'm shooting for 2.5 or so, and well, believe it or not, all it says in the manual is make match marks before you remove the old one, and then put the new one in at the same marks. So what I'm going to do is I'm going to match the height or the voltage from the front to the rear and just make it the same. So right now the front is at 2.35 volts, and I want to match the rear because we're just going to assume that it's level. So I'm surprised there's nothing else in there about it, but what can you do, right? So 2.35 and 2.35. I'm sure it'll change when I tighten it. Yes. Of course. Slides all over the place. 2.39. This is like really anal, but 2.38. You know me. I need stuff to be perfect. Perfect. 2.35 and 2.35. Would you look at that? That's 2.36 actually. So 2.35 front, 2.36 rear. I'll take it. The steering sensor position, I'm not sure what's going on with that thing, but it's another day. There's no codes or anything. I don't know if it just has to be driven and not messed with like we are now, or if there's anything to do with it. I don't know. I'll figure that out later. So let's tighten this down. There we go. Alright, that's it. We've done it. So again, just to give you an idea, you know, as the control arm moves, this goes up and down. That just changes the height of the vehicle, and then it changes the height of the beam for the headlight. So that's it, successful. If I can find the harness part number, I will put it in the description just for reference. I'm sure it's not available anymore. Maybe it is, who knows, but I'll get some spares from out west where there's no rust and the climate's good and all that. But I do have these for sale if you need a good used one. Let me know in the comments, because I can get these sensors, and that's it. Thanks for watching. Hopefully this will help you fix your AFS system. Don't just pull the fuse. That's not the right way to do things. See ya. Take care.